two inequalities at one time. So how do we deal with that? What we call these today are compound inequalities. What we've worked with so far have been a single inequality. Now we'll work with two inequalities at the same time. Not a huge leap, but it is a bit of a leap. So let's jump right into it and let's go at this. All right. No matter what we're doing, one inequality, two inequalities. On the first couple examples that we have there, remember, to be a solution on an inequality, if it's given to you as a graph, you got to be in that shaded zone, that solution zone. And then if you're on that specific point, that endpoint, what does it mean? If you're closed or open. If you're closed, if you're standing on that point and closed, are you part of the solution? Yes or no? If you're standing on the point's closed, are you a part of the solution? Yeah. If you're standing on that point, and that point is closed, closed means, again, you are part of the solution set, we say. If you're standing on that point is open, right? It's not part of it. It's not inclusive. So let's keep that in mind. We all have pencils now. And let's get ready to go through and take that first one really quick. And I'm going to give you just a quick 30 seconds here. I want you to go through and what you think are the solutions for this first one. This row right here, just circle which ones do you think are a solution set to this inequality that I have here. Again, it's a compound inequality because we have two solution areas. You circle which numbers you think would be part of the solution set. Give you 30 seconds. You answer it out. There's, yes, more than one answer that are out there. Okay. You circle any of these that you think would be part of my solution set. Give you a moment. Let's go here. All right, Tyrez, let's have you start off. What did you say in that first one? Did you say 0, yes or no? No. Let's come up the row. Michaela, -6, yes or no? Okay, Shelby, what do you think? 5, yes or no? Now 5 is on the point. 5 is open or closed. Closed, and what do we say? Closes. That's a, yep, that's a yes. So 5 is part of our solution. Come up the row, Jaden. 42. I'm sorry? Yeah, 42. It's way down the road, isn't it? That arrow continues on. 42 eventually is. Matt, -6.5.
Yes.
-6.5 is right here on the left side of it in this shaded zone. And then square root of 49 is code for what?
-7.
So we're really looking at -7. And what do we say about -7? It's a solution. I think it's what you're trying to say there, Andrew. That's it. That's all I'm looking for. Okay, another quick minute. Take now number 2. Let's take a look at -8. Is that working for either one of those?
Yes.
Either one. Which one's it working for, Matt?
It's working for the one that is less than or equal to -8.
Correct. So the first one is good. It's got to work for one or the other. The first one looks good. 64.5 is greater than 8. So that is another acceptable one. It's one or the other, not both. Is 0 working for either one of those? No. 0 less than -8 is not true. 0 greater than 8, not true. Okay. What is -17.5 represented as?
-8, -8.5.
Right. So now, looking at the decimal there, -8.5 is less than -8. So with that, that did it for us. It is less than -8. Cool. All right. After that, all right. 8.0875 is greater than 8. And lastly, -8.25 is less than -8. This one had quite a few options there. Everything besides 0. Remember, or means one or the other. It doesn't have to be both. It's not going to be both. Okay, it's one or the other will be or. It doesn't have to be both. It's one or the other. Okay, so what we just did here leads us into the next piece where we're going to graph these out now. So take that colored pencil of yours. Okay, and we want to graph the inequality with the colored pencil. X is less than 3. So take that colored pencil of yours, pick what color, I don't care, and let's go graph X is less than 3. So remember, X is less than 3. Let's go put 3 on there. Is 3 going to stay open? Or is it going to go closed? Krista says it's going to stay open. Now, when we say less than 3, one more time, which way do we shade? Less than symbol is going to the left. That is correct. So let's shade it. And don't put a dark shade on there, just enough to shade it to the left with your colored pencil. Because what we're going to do is have a couple things shading on this, okay? Shade it to the, what you say? Shade to the left, colored pencil. Because we're going to shade two things at once and something's going to happen here. Take your other colored pencil. Go with green now. We're going to go -1. Krista? We'll get you in line here. Okay? -1. -1 is going to do what? Open or close?
Open.
And it's going to go to the right. Because it says greater than. Shade it to the right. Now, as I shade that to the right, what we're looking for here is, it says shade now with your, we're going to just go with our regular pencil now. Your regular pencil. It says shade where it says it's less than and it's greater than -1. So what do they mean when it's less than 3 and also greater than -1? Which part of the number line? We've got 3 sections on this number line now.
1, 2, and 2.
We've got here, here, and here. We got 3 sections. Where is our number line considered to be less than 3 and also considered to be greater than -1? Matt?
0, 1, 2.
Right in between there, right, guys? So here's the part where it's less than 3 and it's also greater than 1. So as I get Andrew and Matt saying right here in between, let's take our regular pencil, and what I would like you to do then is now actually go through with your regular pencil and shade that in very, 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 very darkly. Okay? And with that, that is our part that is considered to be the and. So with our colored pencil, let's go and write the word and right there. That is what? X is less than 3 and, right. What does and mean again? It has to be both. So in between, and then we see that graph a few minutes ago, up above. Up above on number 2. We saw that happen right here. We had an and happen right there. Okay, what's the next one ask us to do? Let's go back to the color pencil for the next one, number 6. First thing we're going to do is less than or equal to -4. Go to 4. -4. We're going to close -4 or leave it open? We're going to close it. So with your colored pencil, go ahead and close it. And which way are we going to shade that -4? Left to right? Left to right. X is less than, we're going to go to the left. Okay? Flip it to the other colored pencil in this candle gave you. Go to 0. Open or close? Open. Left to right? And go to the right. What does it say? It says X is greater than 0, doesn't it? X is greater than 0. Greater than 0 means go to the right. Now, when I go to the right, are these ever going to overlap like our last one did? No. And the reason why this last one's never going to overlap is what's our word on this one?
Or.
And or means either
One or the other.
doesn't matter which one. Either or. Could be true for either one of those. Correct. Doesn't have to be for both of them. So let's put here, I'm just going to put it right there above it, the word or. And that's the type of graph a lot of times goes with the word or, where they go in those opposite directions, they don't overlap. Okay. So we saw that graph up above. I think it was maybe the first one we did. Okay, where we saw that word or. I didn't give you the word or, but I gave you that graph that started off with that. These are never going to overlap. Okay, I think I gave you maybe here now. So let's finish this thing off. Let's go graph this out. Okay, what I like us to do then is, let's go graph out these here. Go graph me out x is less than or equal to -4. Okay, go graph out that one and then graph out the second one. Or is greater than 2. Yeah, that's what we gave him for you. And that's where it'll probably be helpful for you there, Jayla. Just kind of see that. If it's not helpful for you, fine. I will probably use those colored pencils as I'm up here with you, Ms. Keel and I. Biggest thing I'm looking for is when I grade these, Ms. Keel and I, your first point's going to come from you showing us if it's open or closed. If you can't tell us open or closed, that's you're dead on the right. -4, open or closed. Close. Okay. And the next thing we're going to be giving you a point off of is, well, which way you're shading that -4. Correct. Okay. Second thing is, go graph me the other one. What's 2 going to represent? Open or close? Thank you. 2 is going to be open, right? And we're going to go to the right. And are these, again, ever going to overlap? Now we graphed everything correctly. Those are not going to overlap. So I'm not going to use my other pencil to like shade in between. They're just never going to overlap. So what does that mean for our solution? Do we have to be in both of those? I can't I? No. I'm straddling like the line here. I got to be in one or the other. Now this last one, we haven't looked at this notation style just yet. We're going to do that here and then we'll move it on. This last one's a bit funky. Okay? With this last one here, all right, let's go start at 1 and 3, please. We'll put a 1 and 3 up, put a point there. 1 and 3, let's put our dots.
Ain't it closed?
What's 1 going to be? You said close, right?
Yeah, so it's 3.
And so is 3, right? Because of the equal to and the equal to. That doesn't change anything. That's absolutely correct. Closed on both of those. That's absolutely correct. Now, what's happening here on letter B, our use of the word and is happening here. But in math, we usually kind of condense this down. Not with the word or we usually leave separate here. The way letter B is being phrased, B is being written like we did up here. Okay? What usually we do here on this one is we take this word of and we usually rewrite this like this in the word and. So when you see this compound inequality going the same direction like we have here, 1 is less than or equal to x and x is less than or equal to 3, this implies we have a use of and happening. And where do we shade? In the middle, right, in between. So we have our solution set right there in between 1 and 3. 1's a solution, 3's a solution, and everything in between 1 and 3. 1.5, 2.5, 2.999, not past 3, but 3 is. Okay. All right, flip, go. Let's do a couple on the back side, and we'll call it. All right, we're looking okay on time. All right, students are to present a persuasive speech in English class. The guidelines state that the speech must be at least 7 minutes, but not exceed 12. All right, Weston, get you in line here. Okay, we're going to talk about our variable and inequality and put a graph on there. When we say the variable says specify the variable, that means define the variable. We don't care what type of variable you want to use, A, B, C, X, H, N, whatever. Typically just go with X.
So no matter.
Nope. And in this case, what are we talking about in this variable? Oh, sorry, in this scenario? Kind of the
cannot be less than 7. It cannot exceed 12.
yeah, our speech and what are we
Let's say
doing?
7.
We're talking about time, right? So X is representing our time, right? Time of speech. So what's occurring here is our independent variable, our time of our speech. Now, what represents what is our inequality that does this? Is what type of inequality? Now, we just did that on the other page. What do I mean by did that? It's going to look like one of our last two here. Either A or B. Like this or like this. So, must be at least 7 and not exceed 12.
So at least
So, can I be less than 7 minutes? Can 3 minutes be okay?
No.
3 minutes speech okay?
No.
No. Is a 20-minute speech okay?
No.
no.
So what do I want to be? Where's my sweet spot?
9.
9, 7, 8, 9, 10, 11, 12, 13. I'll put 6 on there. So let's think about this. 7 is 7 okay? 7 and 12.
Yeah.
I know I'm right there. 7's okay. At least 7. If you go up there and you do your speech for 7 minutes, is 7 going to be okay?
Yeah.
At least 7's fine. And if you go up there and speak for the whole 12 minutes,
What makes it close?
at least, the word at least does that. If you go up there and speak for the whole 12 minutes, and they're going and say it's 11:58, 11:59, 12, you're done. Are you still going to be okay? Not exceed 12. You stopped right at 12 minutes.
Yeah.
Are you still okay? So that means 12 is closed. Now, where are you shading? Where's
The
your sweet
middle.
spots?
middle.
The middle. Correct.
So it'd be in.
Thank you. That's what I was looking for. Right. So what's that inequality going to look like? It's going to look like the and, as Jayla said, which is going to look like what we did right here. From 7 to 12, 7 to 12, and you just said 7 was okay, 12 was okay. 7 to 12. Okay? They said give me at least one solution. Andrew said a second ago 9 minutes was okay, 10 minutes was okay, 7 we said was fine. It's the bare minimum. Okay? But 6 you said was not cool. 20 minutes you said was not good. Right. Okay, let's go with one more. Letter B, and we'll call it after letter B. Letter B, you receive a discount on tickets at a movie theater. To receive a discount, a person must be between the ages of 2 and 12, including 2 and 12, including 2 and 12, or 60 years of age or older. So our number line is not going to be like super exact, but what are we talking about here? We're talking about ages, right? Now, 2 and 12. And then we jump to 60 years. So our number line is going to kind of jump around here. Let's go with 0, 10, 20, 30, 40, 50, 60, 70. That works for us. Now we're at what? 2, 12, and 60 are like our numbers up there, right? So let's go highlight 212, and where's 60 at? Person must be between the ages of 2 and 12. Are we gonna close 2 and 12?
No.
Person
Yeah.
must between,
Yes.
because it then says
Included. So, yeah.
You're gonna be both closed.
they're both can be closed. Cool. And then it says 60. Are we gonna close 60?
No.
Cause it
Yeah.
said,
60 years of age or older. Now, where am I going to shade?
So the first two are going to be connecting to each other, and then 60 is going to be going to the white, correct?
Yeah, because of older, 60.
so you're going
Correct.
right.
60, 61, 62, 70, 71, 80.
90, 100.
I guess so. Can go to the
110.
movies, right? We can do Weekend at Bernie's style, I guess. Okay, anybody? No? Okay. All right. So what is another solution that would also be working in this scenario? I just rattle off some. So did Andrew 100 work?
65.
Would 9
Yeah.
work? Would 14 work?
No.
No, 14. Then you just get some regular price. Okay. 9 we said. 65. Would 3 work?
Yeah.
Right. Okay. And there's a whole bunch more possibilities. Okay. Now the last one here.
Are you going to do the equality?
Yeah, the inequalities can get a little funky. All right, because on this one it's got 2 that we've talked about. It's got the and, as Jayla pointed out a few minutes ago, and then it's got just the single one with the or. Right. So this one gets a little odd. But that's how the ticket prices work at a theater. You got child prices usually. You got just then regular like adult prices where most of all of us are at. And then you got like senior prices, okay, where your grandparents usually are at. Don't put me in this keen on those grandparent prices, right? Not that old. Okay, so you do have that type of scenario working in this situation. Okay? Now I'm gonna leave it there because it does get a little weird as we write that out, but that's where we're kind of at. Okay, as I will write out, I'm not gonna stress on it. Not 0. We said 2, didn't we? We said 2 to 12, or greater than.
Wait, should 12 have
I was going right back to. Thank you, Andrew. 2 to 12 worked, or you had to be older than what? 60 years old. So when you go to those type of places, that's how we're working those. Okay. And again, that's how. You don't think of math like that, but that's how it is phrased. Okay.